My name's Randall Nagy. Thank you for joining me for this module on Object Orientations, Part 1. Object orientation is often a topic that causes new software developers a good deal of concern. It is one of those things also I've discovered that it takes at least 3 times to truly understand it from an implementation point of view. One of the things we have to begin to understand object orientation is Java constructors. Why? Because constructors allow us to create objects based upon the requirements that really should be specified at the time we're turning our recipe into an object. Next, we have to talk about our inheritance order, as we begun to see later on, how things are related together so that they can actually begin to call from A to B to C, as well as to implement other relationships that might break out of that inheritance chain. Finally, we're going to talk about and revisit the idea of looking at object parentage so that we can understand how to override as well as overload methods using keywords that has the same annotation. Finally, we're going to talk about the order of construction, which is important to understand, certainly when objects are being created in the background in that private area, what we can use and when as our objects are being created for us. So at some point in time, to review, we know that everything inherits from java.lang.object. We have a lot of free members to override, and although most people don't have to override any of them, usually the get string and toString and hash codes are the first thing people consider to override whenever they want to have string representations of their objects and memory locations that are absolutely defined by what is inside of them rather than where they reside on memory or in memory. Every complex type in Java also has a free constructor. Just like we never saw us actually extending object, and the compiler did it for us as well, every complex type or every class has a constructor that Java creates for us for free, and it's used whether we know it or not. Of course, when we provide the constructor itself, we'll see that we have other things to consider about whether other constructors can be used and what order we can use them. So, once we have a default constructor, as the name implies, it's always used by default and it takes no parameters. So, when we have 3 objects, as we see here, parent 1, parent 2, and parent 3, you must realize that we have 3 default constructors by default. We also have keywords that are associated here as well. We have begun to see and appreciate how this means exactly as we understand it to be. This means what is happening right here and right now in our own object. We've also discovered how super can call a parent member or a parent value, and we can use that to help us navigate between the ambiguity that exists when both we and our superclass or parent object have something that's named the exact same thing. While at some point in time you can appreciate that any parent, for example, parent 2, has a super relationship with his parent or her parent, as is the case with parent 1, we, from our very low level, cannot access that capability at all. In short, this refers to ourselves, super refers to our parent, and there is no way to go beyond super. In other words, there's no such thing as a super duper that allows us to do things like access our grandparents as we can do in other languages like C and C++. So visibility has a different meaning as we begin to start looking at member function as the way they handle themselves in a change. For example, if each and every one has a foo or a bar or a foo bar, then we understand we're in an overloading situation. What if, for example, our implementation of our parent doesn't have a get foo? Well, it's a lot like looking at a filter, isn't it? If they don't override it, then of course we can call our grandparents simply by using super, because although it'll look for our parent super, it doesn't find it, and we will get our grandparents' implementation. Of course, if we did have get foo here rather than get bar, it would be intercepted, and now the parents would be called. But keep in mind, just because I'm using the super, all I'm talking about is what is above me, not necessarily what my parent has. Easy enough to understand, but from a design point of view, it can have some amazing implications as we may change one without changing another. So what happens if the parent implements a get foo later on? Obviously, we will see that it will get called as we expected. So what always happens also in a point of view from the constructors is that, as we mentioned, we always get a default one. If we said class parent one extends object, we begin to start creating the exact same code that Java usually and automatically creates for us. In this particular example, we're going to have parent 01, and we're expressly telling it that we're going to extend object ourselves. Don't bother doing it for us because it normally would happen automatically. And moreover, we're going to have our own public constructor. We don't want you to use your public constructor that takes no parameter because we're going to do that as well. To prove to ourselves that we actually do have invisible construction going on or using construction at all, the classic thing to do is to use system.out to print the fact that we're being constructed as we actually have our objects turned into instances. Well, what happens? Well, we're going to basically review the capability to override the object, but more importantly, we're going to see that we can call super directly, which was also typically implied as we construct our objects. So in this case, parent 3 is going to extend parent 2, but we're going to say, well, you normally would do this, but I want to tell you that we want to use the default constructor in my super class. To move back up, what will happen, of course, is he's going to expressly call this parent 01, that's going to be anonymous for super, and we're going to use the default constructor, and we don't typically have to have a default constructor. We can have parameters as well, as we'll see shortly. So far, we haven't done much different than what Java does automatically for us. To review the previous slide, we have the implementation that Java would normally put for us with our own println to prove to us that a constructor has been called. Now we're simply having another parent, and rather than having Java create and implement its own way of doing business, we're going to say, we'll know what you're doing, we're going to do it ourselves, but now we want to call super, just like you would, but say parent 03. So here we have all of the implied constructions that we normally get for free by that syntactical sugar in Java happening to us and for us real time by ourselves, with the exception of actually printing out what's happening in our constructor. Once again, this is something that always will happen for us by Java as we move through time. So how does it work? Well, if what we've done so far maps directly with what Java automatically does for us, then when we call super, we're going to walk up the chain. When we create things, and which explicitly the way it's done, we just document it using println, and then once it's completely constructed, it would obviously come back from that same member function. So we call up a stack of objects in the parentage point of view, and now we're going to return in that self-same order down that stack, and this is the default way that Java creates and instances or instantiates our objects for us. It's called the construction order, and a good exercise when you're just getting used to it is to put println statements everywhere, talking about and verbosely telling what's going on. The difficult problem here is when we want to have, for example, something happen before superclass. We can't do that from the parent 03 constructor. The rule in Java is that whenever we use a default constructor, whether it is something that we may have or whether we're doing something from our superclass, it has to be the very first thing that occurs in our constructor. Why is that? Well, because if we start using other member functions before they're initialized properly, it could cause some problems, couldn't it? For example, if I have my name up here and it hasn't been defined yet and the string variable doesn't work, then we're going to have a null situation if we're pulling that information from the database. And if I tried to print it in a child, it would explode on us quite dramatically. So the rule is hard, the rule is fast and the rule is forever, we always have to initialize our constructor first thing in any constructor, whether it's created by us or whether Java is doing it for us. So the implied order is easy to understand. At some point we know that we have the same package. We know that one constructor, whether we do it or not, is going to cause the other to be called. So if we remove the superclass, a good example would be to see and prove to ourselves that we get our messages in the same order. I would encourage you to just pause the video at this point in time and type this particular exercise in using your own tools and try both the super method as well as the implied construction method and verify to yourself that indeed the implied order is always honored by the Java compiler. Go ahead and do it now. We'll wait for you. The astute student would have realized that at some point in time we needed to have a main function, and using the new operator would have certainly been part of our implied order exercise. For example, if we would continue our previous example to have our anticipated parent 3 in our main, we would see, as we extended parent 2, that we would have all those constructors called in order. Thank you for joining me for our first part of the object-oriented series. Looking forward to seeing you in the next module.